This video, I'm going to be talking about how machine learning can be used in credit risk model development. I'm going to be discussing an EBA paper of machine learning for IRB model. It's a pretty recent paper. So the paper starts with a bit of an introduction about the current landscape for credit risk model building for the IRB purpose. Okay, and it starts with the statement that IRB modeling has not changed much since last 15 to 20 years, and that is true. We have been using the traditional techniques for IRB model development ever since, and the focus has been more on challenging the DOD or the definition of default and less on the modeling technique. And that's a problem actually, and there's hardly any emphasis on improving the modeling technique. The only thing that is changing is the definition of default, nothing more than that. And there is almost no focus on big data, machine learning, AI techniques for IRB model development. And we're still using the standard regression models, which may give suboptimal results for IRB data. For many situations, standard regression models do an amazing job, but for some cases, for example, LGD model development, these models are not necessarily the best models. However, banks are using and have started using machine learning models for credit approval. Right? The models used for credit approval are not necessarily the IRB models. Some banks use the IRB models even for credit approval, but many banks use separate models for credit approvals, and these models do not go through the regulatory scrutiny as much as the IRB models go through. Okay, and now regulators see opportunity in using machine learning and AI models. In the non-regulatory areas, there's still some use of ML and AI, but in regulatory areas, there is hardly any use. And it's a good thing that now regulators are thinking about it, and this discussion paper is just the beginning of what is going to happen in the future and whether ML and AI will be used in the regulatory modeling space or not. Okay, bit more on that. Regulator acknowledges the fact that there's lack of understanding from the supervisors. I think supervisors do not really want to review AI ML based models. Some banks have attempted to build models, but they haven't really received good results, and that's the reason why there is now much less interest in these kind of modeling techniques. Interpretability is an issue. It's not just an issue in IRB model development, it's an issue in all kinds of uses for ML and AI, not necessarily in banking alone, but even elsewhere. But in other industry, interpretability is less of a concern. But in banking, where billions of dollars at stake, you need to be able to understand the models that you use for decision making. So interpretability is an issue for AI model and ML model development. Overfitting is an issue. Many AI and ML models suffer from overfitting, but this is less of an issue in my view because there are ways in which you can deal with overfitting. I'm a bit surprised to know that regulators have put a lot of emphasis on this. If you do a proper cross-validation, you can get rid of the overfitting. But yeah, of course, you can never be 100% sure about overfitting. Things might change in the future and it could lead to overfitting. Linear and logistic models are also ML models, by the way, but simple ML models. So linear regression and logistic regression, which are the traditional statistical models used in credit risk model development, are also in principle ML models. However, these are simple ML models. So in this particular discussion paper, we are talking about more complex ML models. For example, bagging or boosting, random forest, or even deep learning models. Okay, so we're not going to be talking about linear logistic regression model or simple decision tree models. These are by definition, yes, ML models, but the emphasis is more on complex models. Okay. And how we determine the complexity of models, the criteria we use. Number of parameters, the ability to capture non-linearity. Now, linear and logistic relations are not that great in capturing the non-linearity in the model. And then the amount of data required for ML and AI models, we need a huge amount of data in order to have better performance. That's not the case for linear logistic regression. Use of unstructured data, that's again a difference. So based on these criteria, we decide whether a given ML model is complex or is a simple one. The current uses of ML and AI in banking. It's used in credit decisioning, as I mentioned earlier. But however, it is avoided for capital provisioning and stress testing model development. So it's not just for IRB capital models, even for IFRS 9 provisioning models. I do not think any banks currently using ML models. Even for stress testing, none of the banks are using, at least in Europe, using ML models. But also used in many other models beside credit decision models to build challenger model for IRB, for provisioning, for stress testing purposes. Now, challenger model is not a final model, but that's a model used for benchmarking purpose. Okay. Data quality improvement, for example, in anomaly detection, some companies are using that also, and for variable selection. Some of the other observations regulators have, banks are less interested in using ML in regulatory area. That is true. Banks are, in my view, capable of using ML models in regulatory areas, but nobody wants to deal with the regulators because that's a difficult job. It's very difficult to make regulators happy, and you spend a lot of money actually building models, and you do not want regulators to reject your model, and that's a fear most banks have, so they do not want to take a risk. So yeah, so that's the point. So avoid regulatory hassles. None of the banks are interested to use ML and AI in the IRB model development. But now that regulators are interested and showing interest in these models, maybe in the future, in the near future, banks will use these advanced techniques. But people still use collect for model building and collection, for example, building a collection model or credit approval. We have already discussed that. However, regulators are now welcoming discussion on added value of using ML techniques. So that's a good point, right? Not just European regulator, but also in the UK, in the US, and in other countries as well. Now, these are some of the questions you can find in the discussion paper. For example, here is the question: do you currently use or plan to use ML models in the context of IRB in your institution? If yes, please specify an answer. If not, are there specific reasons not to use ML models? Please specify: too costly, interpretability concerns, certain regulatory requirements. Right. So regulators are interested to know what stopping banks using ML and AI in IRB model development. Is it only the regulatory requirements, or are there more things? Is it too costly to build ML models, or is it the interpretability which is the concern? In my view, it doesn't cost more to use machine learning techniques instead of linear regression, logistic regression. I think the cost comes from this data collection part. That's more of an issue rather than choosing a specific technique. So that should not be a thing. There could be other reasons why banks do not use these models. For example, cost of implementation, right? It may not cost too much to build advanced models, but it may cost too much to implement such model in your IT system, and that may not be something banks want at the moment. The other questions also, if you want to have a look at these questions, please go through this paper. The link is in the description. You may even write to EBA. You want to give a recommendation, that's fine. Obviously, they will only listen to the banks. If you want to do it that on your personal capacity also, that's always welcome. There are some regulatory challenges. Of course, there are regulatory challenges, we all know, and regulators have acknowledged that, and some of them are here, and they have discussed these challenges in this paper. The definition assignment criteria to grades and pools, and that's the first challenge they have mentioned. It's not very clear if you just read the title here, the heading, but they are mentioned in detail. So I have just summarized, but it's a long paragraph. Okay, so it's nothing but the lack of economic relationship between inputs and output, which is an important thing in IRB model development. You should be able to assess the economic relationship between a given risk driver and your output. For example, in the PD model development, the output is your rating, the credit rating. Okay, so that should be properly assessed, and for machine learning models that may be an issue. In my view, it's is not an issue in some of the machine learning models, but it may be an issue. For example, if you build a PD model using a deep neural network with multiple layers, and it's difficult to actually find a proper economic relationship in such a model. But you can do that outside of the model also. That's not something discussed in this paper. I was a bit surprised. Institutions should look for suitable tools to interpret. So interpretability is something that is heavily discussed in this paper, that we all know that ML models have issues with interpretation, but we do not need to be able to interpret every single thing, in my view, but regulators are very concerned about it. Some of the things can be also understood or interpreted outside of the model, and you don't need to understand everything what's happening in the model, but that's just my view. Okay. Complementing human judgment. In machine learning model building, sometimes you have to decide what is known as the value of a hyperparameter. If you're familiar with machine learning, I'm sure you know what hyperparameter is. So hyperparameter is different from parameter. So parameter is estimated within the model building process, whereas hyperparameter is decided outside of the model building process, and it's something decided by you as a model developer. You can use some standard techniques, or you could also use human judgment for that. Okay, and that's a concern in IRB model development from a regulatory standpoint, because how do you substantiate your judgment? That's a concern. So that's a difficulty. The third one is documenting model assumption and theory behind the model. It would be a challenge for the ML model. In my view, that's not a concern at all, in my view, because the ML models are also theoretically quite strong. If you ask a computer scientist, he will disagree with this. I think this research paper has been written by economist or statistician, and they may be worrying about whether the theory about ML models is very clear or not. That's not necessarily the case. I think it's quite clear, and you can write about these models. Maybe the neural networks and all, where theory may not be too developed, but for example, a random forest or a boosting bagging model, theory is quite clear, or even a support vector machine. You can write the theory properly and explain it in the document. However, regulators have some issue with that, and they have pointed this out here. The more challenges, for example, plausibility, intuitiveness of estimates. ML models can result in non-intuitive estimates. That's true, because in machine learning, what matters is whether you are able to predict the outcome or the target variable. You are less bothered about whether the estimates are intuitive or not, whether there's a proper economic relationship or not. It's all about prediction. Whereas in econometrics, you also care about the marginal effect, right? The beta parameters, intuitiveness of beta parameters, so on and so forth. And that's a philosophical difference between how we build an econometric model and a machine learning model. So this concern is is a fine concern in my view, and I think regulators have a real concern on this, that you may be building models that which are good predictors but may not be intuitive, and it's difficult to understand. Then the other concern is the length of underlying historical observation. So this might be a problem for unstructured data. In IRB model development, you need at least 5 years of data. Okay, and you may not have 5 years of unstructured data for given variable, but you could also exclude these variables, right? So that should not be a problem. GDPR rules. So for some personal information, you cannot have data for more than 5 years, and we may want to use such data in ML model development, but that is not acceptable to regulators, because you need to have 5 years of data. Okay, then other challenges, here is one. So difficulties in understanding the findings from model validation. I found this quite funny, because yeah, the findings from model validations are always difficult actually for the model developers. So there's nothing new, but here it is about difficulty in understanding the findings. Well, I don't understand as to why that could be an issue. I think the findings should not be affected by which modeling technique has been used in the model development. And yeah, it can be written in plain English and can be understood by yeah, anyone. So why is that a concern? I don't understand. But maybe because of the complexity of the model, you could have more findings, you could have more complex findings, and that interpretation may be a bit of a challenge. Model validation will be a challenge, that I agree, because complexity of the topics will be more. You have hyperparameters, best hyperparameters, and the model developer might have used some human judgment in deciding the best hyperparameter. So there may be debate between model developer and model validator about the substantiation part as to what is the best hyperparameter. Okay, and also in some experiences I've heard, yes, people have issues. For example, people have issues in validation. Also, people have issues in deciding how many risk drivers to use in the model, what the best set of risk drivers. So these issues are not new. Even in traditional model development, you have these issues. Maybe you have more number of issues with machine learning models. And then the last one is the IP implementation challenge. That's something I have already discussed. Some banks are not ready for that. You do not have IC systems where you can implement complex machine learning models. That's the real challenge in my view. Yes, so here are a few things they mentioned. I have taken a screenshot of that. For example, for tree-based model, you need to decide the depth of the tree, and that's the hyperparameter. And it's not very scientific as to what should be the optimal depth of the tree. It's difficult to find that out scientifically. In a neural network model, you need to decide on the number of nodes, right? You will obviously go by the cross validation, right? And it's a back and forth thing, right? You develop the model, check your performance in the validation data, and then rebuild the model. You do that back and forth, and it takes a lot of effort to come up with the best model that gives the best prediction in your validation data. However, it's difficult to write down about how you came up with the best number of nodes or the optimal number of nodes for your neural network. So yeah, decision on hyperparameter is a big challenge, and I agree that it's difficult to argue what is the best hyperparameter for a given model. Even on parameters also, it may be a challenge. For example, finding out on weight, yeah, variable and thresholds and everything, right? Like in classical models, you can enforce your parameters to take certain values. I'm not 100% sure if that's also possible in machine learning. You may have to write down your own routine for that, but I'm not sure the standard packages available in R or Python allow you to do that. So that may be a problem. Okay, I'm not 100% sure though. But there are potential benefits also, and regulators acknowledge this. These models actually can help in improving the risk differentiation. For example, improving the discriminatory power of the model, or the model performance in general can be better with ML techniques, and could be used in finding most relevant risk drivers. That's true, actually. We use stepwise logistic regression, that's fine, but I think if the dimension of the data set is very high, it's also a bit difficult to use stepwise logistic regression. ML models could do a better job, I agree, right? So in computation platforms like Kaggle and all, you see more complex models always winning the contests, right? So it's likely that you will have better performing models with ML techniques. ML models can help in optimal segmentation. So something I think we have discussed already. Useful in LGD model development. We have also discussed this point. LGD model development is very challenging actually, because the recovery pattern follows something like this, right? It's not a very it's not a pattern that you can model easily. So ML models that can take into account the non-linearity in relationship are more suitable for such a pattern. So yes, ML models can actually improve the performance of a LGD model. Data quality checks you can determine on the outlier detection, anomaly checks you can do. You can use unstructured data. You can also use ML models for collateral valuation. So this is also another important thing. Collateral valuation is also a big challenge for the banks. The traditional techniques used in these may not be very suitable. Some banks use only linear regression, but you can improve upon that. Identifying adverse scenarios for stress testing. Yes, you can do macroeconomic forecasting also. Although in my view, I think the time series models, the traditional time series models are actually quite good, and the value addition is much less in my view. One interesting thing in this paper is that they have repeated the same point again and again. So this paper is, I think, some 25 pages. It can very well be summarized to just less than 10 pages. Okay, it's the same point they're just repeating again and again. But one thing that is clear from this paper is that regulators now see potential benefits in these models, which is a good thing. So there are a lot of recommendation actually for good uses, but I do not think. Yeah, so these are the recommendations. The ML models might add value provided they ensure acceptable monitoring, validation, and explainability of methodology and of the model outcome. That's a very generic statement, but they have clarified with specific as to what needs to be done. So first point is about staffs need to be trained in these models. In many banks, econometricians or statistician work. You don't have machine learning specialists working there, so specific trainings should be provided. That's a good point. Senior management should at least have high level understanding. That's a good thing also. Should avoid excessive number of explanatory variable. Okay, a good thing, but it's not very clear what is excessive number. Okay, I think that's something regulators should also specify, and also specify as to why that is an issue. That point is not very clear. Should avoid unstructured data if structured data can do the job. That I think goes without saying. Nobody will put effort to collect unstructured data when your structured data can do the job. So that's quite obvious. Should avoid complex models if simpler models give same result. I think that is not just applicable to ML models, it's also applicable to classical statistical models also. So that goes without saying. Should analyze the output and input relationship in statistical manner. That is true. because it's not just the prediction accuracy that matters, it's also about the relationship between the risk drivers and the model output that matters a lot in IRB model development. So it's also a good point. But the point is that it's not very clear in this paper as to how these things can be done. But this is not a detailed paper. Maybe they will come up with a detailed paper in the future. More recommendations. The banks need to assess economic relationship between variables and check the intuitiveness. That's something we have already discussed. But this is something banks need to do even with ML models. And that's a challenge in my view, especially if they're using neural networks. Ensure potential biases in the models. For example, overfitting to the training data are detected. This is less of a concern in my view. Even with the traditional statistical model, banks are using a lot of validation techniques, cross-validation techniques, so that should not be a problem. Deeper understanding the model is needed when human judgment is to be used. So if you're using hyperparameter, one should understand the model building process even at a deeper level, so that you don't induce any bias in your judgment. It's a fair point. For complex model, validation should be stricter. Well, validation is already quite strict in my view in most banks, and okay, it's subject to debate, but that's also a fair point. For example, so what is strictness? So strictness concerning these points, 4 points. Checking overfitness issue, I think validators are already checking for that, so that's nothing new. Rationale behind choice of hyperparameters, a new point I would say. It's not an issue with classical models. Assessing representativeness of external data, that's we're already doing, nothing new. Rating assignment process, avoiding PIT model fit. And this is an issue, actually important point. ML models could be so well fit that it could end up having a point in time model fit, which could change with time, right? But we want a through the cycle model fit for IRB models, less varying, right, with time. Well, that could be a challenge. So you could respond to this discussion paper. As I said, banks obviously will respond, but you can also respond in your individual capacity. So if you want to respond, these are some guidelines. I think there are also details of the contact details you can find in this paper, and you can respond to the regulators with your points. The link can be found in the description. So thanks for watching.